Hi students, good morning. Okay, today we'll see the how to write a truth table for the two variables, three variables, and also four variables. Okay, from the truth table, if you any binary combination have the higher the position of one, the value of one, that is to be considered as the term to in the boolean function. Even we'll see the how to write a boolean function from the truth table. Okay, from the truth table. Okay, from the truth table, obtaining the truth table, obtaining the boolean function from the truth table, that boolean function has to be implemented with what here the basic logic gates. How to write the basic logic gates will be used for the writing of the designing of the boolean function also. Okay, we'll see one by one. Let us to consider the first one as the two variables. Okay, two variables truth table, how to write it, and thereafter we'll switch to three variable and also four variables. Okay, we'll see that one. First one I'll be considering the two variables. Okay, let's me have it. First of all, if I take the two variables means what here the any variable, two variables. Okay, if I consider the any variable in the world, if I tilde a point, that will have the how many options? Two options, either 0 or 1. Yes or no? So that if I have the variable as the x here, that is having the two options as the 0 or 1. That's to be what here the complement of this one x dash. This is to be what x only. So similarly, if I have it, okay, that this one can be written as the x can have what values 0 or 1, one variable. If I have the two variables, if I have the two variables, then I have the x. Let us to consider the x and y are the two variables. X and y are the two variables, so that I can have the four combination of the truth table here. Four combinations. How to write four combinations? 0, 0, 1, 1. This is what we call the binary values, binary combination for the two variables. Okay, for the two variables. This is the truth table for the two variables. Okay, let me have the one function here. Let me, the name itself, the function can be here the f. Okay, from the f. Okay, if the mean, okay, if this boolean function, okay, this is the boolean function. If any variable combinations, okay, if the combination of we have the four variables. If I have this combination have the high position, that is to be considered the term in the boolean function. Yes, no? If I have the any one, okay, if I have the this, okay, this one, okay, this is like this. Okay, if I have the how many terms here I have two terms, okay, two binary combination I have to be okay. For the writing of the boolean function, this to be what x, y, okay, to be taken as the x and y. Here I have how many combinations? What mean terms here? 1 and 2, 1, 1. Okay, this is to be written as the x dash. 0 is to be considered as the x dash. Y1 is considered to be what is the y is the 1, y. Okay, then this is to be what x and y, because of the these are the having the high position values. Okay, that is to be what is the x and y, x and y. This is we call as the writing of the boolean function from the truth table. Okay, from the truth table. Then how to implement this boolean function is the what here the we have the some the variables, that's to be what gates. No, how many gates here I need? What kind of gate here? Dot product is there. That's the AND gate I need here. One more AND gate I need here because of the AND operator. Okay, dot operator. Okay, then I need the one OR gate, so that I can also write this one as the AND. Okay, these are the inputs for this x is x to be what here the x, y is there, x is there, this is what is the y. Okay, I can also write either of one. Okay, if I interchange, that's not okay. Then it's to be what here the, if I take the this one as the x dash. Okay, there's nothing but the x dash is what here the x dash. This is the x will becomes the x dash here. There's this what here the y is there. Then also I can take from the y itself from here only. Okay, this is and for the I. Okay, this the x will becomes x to y. This is what here the x dot y. This is what here the x dot y. Okay, these two are inputs. Okay, outputs of the this faded to one more OR gate, because the we need here the plus operator is there. Okay, plus operator, so that this is the OR gate symbol, so that this is what is the f equals to what here the x dot y plus x dash y is there, x dash y. This is the output. Okay, this is the function of the boolean function which we got from the table. This is the boolean function. This is what here the logic design. Okay, design of the logic gates, logic with the help of the basic gates. We have repeatedly we are using what here the what we are using the one variable, that's what we call as the y is to be taken to the, this is what we call the implementation of the deriving the boolean function from the truth table and derived. Okay, this is whatever we got the boolean function that is to be implemented with what here the basic gates. This is the one part. Okay, from the truth table onwards. Next we'll consider the three variables. Yes or no? Okay, next shall I move to next topic? Yes. Okay, then to the I'll be taking the next topic here, the three variables one. Okay, shall I write this here? Okay, yes. Okay, if I consider the, let us to consider the three variables scheme now. Sorry, three variables to table here is nothing but the, let me have the three variables means x, y, z. Okay, let me have the, let us to consider the, let us to consider the three variables. Okay, this is nothing but the x, y, and z. Okay, these are the three variables. The variables whatever we taken that two variables that to be having the how many combination to the power of n number of combination. Here how many variables are there? Number n is the number of variables. Okay, this how many variables? 2 to the power of 2 is nothing but the 4 combination of high inputs. Okay, this is the decimal equivalent values 0, 1, 2, 3. Okay, these are the 4 combinations. Here are the two variables. Similarly, in the three variables also we have the 2 to the power of 3. Okay, 2 to the power of n equals to 2 to the power of 3 number of combinations of a inputs can have. Okay, that's nothing but the 8 combinations of the binary combination have. Okay, the three variables are here what we have, whatever we consider above, which one? X, y, z. Yes or no? X, y, z. Okay, x and y, z. Okay, this should be what here, the 0, 0, 0, 1, s 0, 1, 0, 1, 1 for the 4 combinations. For the 4 we have the 8 combinations. So 1, 1, 0, 1, 1, 0, sorry, 1, 0, 1, 1. Similarly we are adding the 1. Okay, 1 values to the particularly the previous value. Okay, that will becomes 1. That becomes 1 plus 1 is what? 2 is the 1, 0, like this. Okay, we have the 8 combinations here. Decimal equivalent values for this also we'll write this one here. Here will be this is 0, 1, 2, 4, 5, 6, 7 are there. Okay, these are the 7 means 8 combinations I can have the for 3 variables. Yes, got it? Okay, let me have the function here. Okay, let me have the function here. Function name can be would be here the f here. Okay, if f is the function with the we have whichever the boolean. Okay, these are the values. Okay, variables. Okay, these are the values that is to be what here the variables can have the this type of combination. One combination we call as the terms here. Okay, the term whichever the term you consider, it is to be whatever high, whatever the one. If you are writing, if you mention like this, if you mention like high position, remaining positions are what here the 0 only. The wherever the variable is present, okay, wherever the term is present, that is to be high position, that is to be considered as what here the as a term in the boolean function. Okay, which are those? First one is what here the second, this is to be what here the first one, and also this is to be what here the, okay, these are the combination, these are the terms I can have here. Okay, this is what here the, for this one 0, 1, 0 is how much? 0, 1, 0 is how much? 1 is what here the y, 0 is what is the z dash. Yes or no? Got it? Okay. Similarly, I can write the, this is what is the x, y dash, z dash. Yes or no? X, y dash, z dash, because of the 0 combination. This is 1. This is what 101. 101 is what here the plus 101 is the what here the 1 is what here the 1 is what here the x, y dash, z. Okay, x, y dash, z. And one more is that 7 is that x, y, z. This is the, okay, writing of the boolean function from the truth table also, like this also we can write here. Okay, this is the designing of the truth table. Okay, this is the truth table form. We got the boolean function from the truth table, whichever the function having the those terms high position, that is to be considered in the while writing the boolean function or boolean expression or boolean equation. Yes or no? Okay, got it? Then the designing of the this boolean function. Okay, what your boolean function can be designed with the help of what here the basic logic gates. How to design this one? Okay, we'll see that one. Okay, what where we got this one is what is the three variables are there. 1, 2, 3, 4. 4 terms are there with the three variables. With the three variables. Three variables means what here the, those are also have the having the what here the mean term. Okay, the variables can also have the its complement also. It's x is there, then the x will becomes what here the x dash. Yes or no? Because of the inverter. Okay, if its y is there, y can becomes what here the y dash. This is to be what here the y dash. This is the z is there, Z is there. This is to be what becomes what is the Z dash is there. Yes or no? Yes sir. Okay, this is what is the x, x dash, y dash, z, z dash. We got this one. Well connection here, well connecting here, well connecting here. Okay, we got the three variables with the its complements also. So that we have the how many terms over there? Four terms are there. Which are the first one? Consider the first term as the x dash, y, z dash. X dash, y, z dash is there, x dash is there, y is there, z dash is there. Take this one. This to be what here the AND gate because of the product form. AND gate will be taking the AND gate here. Let us to have here. Okay. Similarly, I can also write the remaining terms x, y dash, z dash. X is there. X take the x is there. Y dash, z dash is there. Okay. Okay, write down after. Okay, copy the things all simultaneously. Okay, I can't wait for the writing. One more time, need to give the time here. Okay, copy this one also simultaneously while explaining. Okay, this is the second term. Okay, this is the second term. Next is what is the x y dash z dash. X y dash z. X is there, y dash is there, and also z is there. Okay, this is to be third term. Okay, next is what is the x y z is there. X is what here the x is there, y is there, and also z is there. Okay, yes or no? Okay, then okay, I have the four terms with the product forms, so that I have the AND gates also with the AND gates. I need to with the sum. Okay, that's to be what here the r together. These are all r together, sum. Okay, sum. Okay, that's to be done with the help of what some OR gate. That's to be what multiple OR gate here, multiple OR gate. Even I can also use the two OR gates two times, and also will be summing to the one more OR gate, three OR gates. Instead of having the separate two OR gates, I am using the multiple input OR gate here. Why? This is what here the function. This is what is the function. Whatever they got here. This is the designing of the particular boolean function with the help of what here the basic logic gates. Okay, logic design. This we call it the designing of the logic. Okay, whatever you got the boolean function, that's designed with the help of the basic logic gates. Which are those? AND gate, OR gate, and also NOT gate. These are the basic logic gates. Okay, this is all about the three variables truth table. Okay, similarly, even I can also write with the now even I can also write with the four variables k map. Sorry, truth table. Okay. Okay, shall I erase this one? Shall I erase? Okay. Okay, the same thing here. If I consider the four variables, then it used to be what? How it used to be here? Let's see. Okay. If I consider the four variables, truth table. Four variables truth table means we have the 2 to the power of n number of combinations. How many? 2 to the power of 4 means what? 16 combinations of the truth table I need here. Okay, 16 combinations. Let us to consider the w, x, y, z are the four variables. Okay, first I am writing the w, x, y, z. Okay, let me have the 0, 0, 0, 0. This is the decimal equivalent value of what is the 0, and also 0, 0, 0, 1. This is equivalent to 1 year decimal equivalent value. Okay, 0, 0, 1, 0. After adding the 1 plus 1 is what here becomes 1, 0. Okay, that's to what here the 2 year. Okay, one thing I would like to remember, okay, remind you, this is 0 plus 0 is how much? Algebraic, Boolean algebraic is what here the 0 only. 0 plus 1 is what here the 1 only. 1 plus 0 is what here the 1 only. 1 plus 1 is what? How much? 2. Yes or no? 2 is nothing but the 1 0. 1 plus 1 plus 1 is how much? 3. That's to be what here the 3 is nothing but the here the 1 1. 3 is nothing but the 1 1. Similarly, I am applying this one. Okay, just I am adding the 1 to here. That becomes what? 1 plus 1 2. 1 plus 1 is how much? 2. 2 is nothing but the 1 0. If I add the 1 more to the to this one, that will becomes the 1 1 here. Similarly, 0 0 1 1. I can also have the 0. If I add the 1 to this one, that will become so much 4 there, 4 there. That's to be what is 1 0 0. Okay, that's to be what here the next 0 1. If I add the 1 to this one, is what this will becomes what the 5. Okay, this is the 5, this is 4, this is the 3. Okay, and this is similarly 0 1 1 0 1 1 1 1 1 0 0 0 1 0 0 1 1 0 1 0 1 1 sorry, 1 1 1 1 1 0 0 1 1 1 0 1 1 1 1 0 1 1 1 1. Okay, these are the 16 combinations I need here. Okay, that's to be what here the 6 7 8 9 10 11 12 13 14 15 combinations. Okay, from 0 to 15 is nothing more than 16 combinations. Okay, this is all about the writing of the truth table here. Okay, these are the combination of the four variables can have the different 16 number of boolean combinations. Okay, value binary combinations. These are the binary combinations we call as 0 0. This binary combination have the equivalent value is what here the 0 decimal value. This binary combination will have the equivalent value is 1. This binary combination will have the how much here the 110 is how much 6. The 6 decimal value. If binary combination of this values will having how much 10 is how much 10 decimal equivalent value. Okay, this is the these are the binary combinations. Whatever the binary combinations, 16 combinations, those two have the decimal equivalent values here. Got it? Yes. Okay. Similarly, if I go with the if I have the one function that's to be named with whatever f. If any function, okay, this binary combination is high, that is to be taken to what in the as a term in my boolean function. Okay, this binary combination, binary combination, if it's a high, that's to be considered as what is the f of w x y z is there. This is to be written here. The one means what here the this is to be what here the okay taken to be in my term as a boolean function term here. Okay, the boolean function is having the so many terms are there. This to be those terms are taken to be as the if any boolean function is high, that's to be that term is taken to be what here the in my boolean function as a term in my term. That's nothing but the 0 1 0 0 is what here the 0 is what here the double dash, that's nothing but w complement. This is what 1 is nothing but a x. This is what y dash y dash z dash. Okay, w complement x and y complement z complement. Okay, similarly I can also have this one. I can also have this one. If any work, okay, you can let us consider randomly we are taking. Okay, we don't have any example here. Just to assuming here. Okay, if it's this term is high, this term is high, this term is high, then this term has to be taken to my as a binary combination. This binary combination can be considered to be as a term in my boolean function. This to be written how? This is what 0 is there. W is 0 is nothing but the w dash. Okay, w dash. Okay, next is what 1 1 1. This is nothing but the x y z. Okay, like 1 is nothing but the w. This is what here the 0 1 1 is there. 0 is nothing but the x dash y z. Okay, this is okay. The wherever the binary combination have the 0 0, that is to be taken as that term, that variable complement form. Remaining variables can be taken as the normal form, uncomplement form. This we call as the writing of the terms. Okay, writing of the terms from the boolean term from the boolean function which is having the high value. Okay, that's the if any binary combination have the high value, that term, that binary combination can be considered as the term in my boolean function. Okay, how to write on this one? Okay, the thing is that this is the what we got here. Let me have write the design with the basic logic gates with the help of the this binary function. Okay, binary function is having which are those variables w x y z. W is there, x is there. W means what? This can also have the what here the its complement form w dash. Okay, Then the x is there, yes sir, x dash is there, x dash is to be designed with what here the not get, that's to be becomes what here the x dash. Then the similarly x y z, okay, similarly we can also design the remaining variables with the complement form also. This is what is the y dash, this is the z dash, okay. There we need the 3 AND gates because of the 3 products forms. 3 products form, the 3 AND gates I need here, okay. That's nothing but here the how to write this one, w dash x y dash z dash is there, w dash is there, w dash is nothing but this one, w is the normal for, this is the complement of the w, okay. This is to be taken as the one line. Then we need what here the x is there, okay, original x is there, this is the normal form, and then the y dash z dash, then take the y dash complement form, y is the complement, z becomes what complement form, these to be 4 to be taken to the one AND gate, the term which is the considered to be one term. Similarly I can also draw with the write it remaining, this is the double dash means what here, one more time I am taking here double dash x y z is there, okay, x is there, x, take this as x, then y is there, y line, this is y dash line, y is taken, if this is the z is there, z dash line, z to be taken, okay. This is the combination of the second term, okay. Similarly we can also go with the next term, that's called the w x bar y z, okay. W is there, okay, take the w from here, and x bar is there, x bar is nothing but x, this is the x bar, x nothing but the x is complement form, y is the normal form, that's the original form, okay. Then the z is nothing but the, this is to be taken to the z is there from here z, okay. Then the this are the 3 terms from the boolean function. These terms has to be where what here the we need here a OR gate, okay. Instead of having the 2 OR gates, can have go with the OR with the multiple inputs, OR gate, okay. That's to be where the this is what here the function, okay. This is the OR, all the 3 terms in the boolean function, okay. I hope you all follow this, have you understood, okay. Shall I move to the next topic? Yes or no? Yes sir, okay. This is all about the writing of the truth table from the variables. How many variables are there? If it's one variable, I have the only one variable can have the 2 options, either 0 or 1. 2 variables can have the 2 to the power of n number of combinations of binary combination. 2 to the power of 2 means how many? 4 combinations I had, and also implemented with the function. We got the function where the truth table having the high position of the function, that is to be considered the term in the boolean function, and also it designed the boolean function, and also designed the what logic design also. Similarly we have the 3 variables also. 3 variables, if it's nothing but 2 to the power of 3 is 8 combination. We have binary combination of how many? 8 combinations. If the any function with the term, that particular binary combination having the high position, that is to be considered the term in the boolean function. Writing of the boolean function we got it, and also designing of the boolean function with the help of what is the basic gates, okay. I hope you are following this one. And also similarly in the for the 4 variables we have the 2 to the power of n number of cells, that's combinations, 2 to the power of 4, 16 combination of the binary values I have. This is the first combination of the binary, second combination binary, third combination, like this. We have the binary equivalent value is the decimal value is 0, this is 1, 2, this binary combination have the equivalent to decimal equivalent to this binary combination have the decimal equivalent of the third decimal value. This binary combination have the equivalent to the decimal value of the 4, like this. We have the 0 to 15 combination of the decimal values. These are the binary combination. Wherever the my function f is 1, 1, 1, remaining also has to be considered as what is the 0. Okay, if I not write on, then it is to be considered as the 0, low position. Okay. Low position, okay. This is nothing but the writing of the boolean function from the truth table, and also we have the seen, okay, how to design the boolean function. Whatever the boolean function we got, that is to be designed with the basic logic gates with the help of the 2 inputs or 3 inputs gates can also have it, okay. This is all about the writing of the truth table from truth table, and also getting a boolean function, and also designing of that particular boolean function, okay. I hope you all following this one. Shall I move the next topic? Yes or no? Okay. Okay. Yes.